Next concept is we are going to focus is another tool we call the decision tree. Decision tree is a schematic models that can be used for multiple consequences and which many alternatives. Okay, and this type of tool we are going to use a visual representation we call a node. There are two nodes. One node we call a decision node, we use a square, and event node we use a circle. Okay, these are the how to draw a node. You draw a decision tree from left to right. However, you make a decision from right to left. Okay, the decision that you are going to make we call an expected payoff. Okay, these are the rule of decision tree. Decision node, which represent by the square, will follow by the alternative. Each decision will rise only one alternative. Whether or not you are going to pick the higher payoff or the lower payoff is depending on the type of decision you make. For example, if your decision is about profit, then your final decision you should rise with an alternative with the best payoff. On the other hand, if your decision regards the cost, your best decision would be the one with the lowest cost. On the other hand, the event node, with the nodes by the circle, will follow by the event. An event node, the outcome of each event is all inclusive, meaning that all events must add up together to form the final payoff of that event. Each event must have probability of that event to happen. And another rule is all probability of event must add up to 100% or 1. Okay, so by this rule we are going to analyze example number 1. I'm sorry, it has to be 1.8, I believe. Okay, and this example 1.8 on your note. We're gonna use an Excel. Okay, so why example 1.8? Because we skip the preference matrix. Once we skip the preference matrix, then example 1.8 will be decision tree. From this example 1.8, you can see that there are two main alternatives. You have to make a decision. You also have multiple or event node. By the rules of event, or event probability must add up to 1. So in this case, the first event, I'm good. Over here, the probability will be 0.5, and second one will be this one, which about 0.6 to add up to 1, and next one will be this one, which also be 0.6. And this gonna be the last event, which 0.2, 0.5, 0.3 become 1. With all event probability, we're gonna add this one. We're gonna call it event node number 1, and then we're gonna do similar for this one, called node number 2, and also we're gonna do this one we're gonna call node number 3. And the last one we're gonna call node number 4, which is this one. Now we can enlarge it a little bit so it easily see. For node number 1, for node 1, we're gonna find out that the payoff will be all inclusive of these two alternatives, so which gonna be equal 0.5 times 15 plus 0.5 times 30. So node number 1 have 22.5 as the outcome. Let's see if we can like that. So next one, node number 2, it's gonna be equal this outcome of the product of these 3 events. So it's gonna be 0.4 times 20 plus 0.3 times 18 plus 0.3 times 24. Which you're gonna have 20.6. Now put it over here. Now let me copy it. Here's it worked the first time, the second time copy. Here's first gonna paste a picture first. Now for node number 3, node number 3 cannot be done without node number 3 can be done first, and then you're gonna make decision on node number. So node number 3 going to be 0.6 times 20 plus 0.4 times 30. Okay, sheet 24. Okay, first copy. Okay. Okay, as you can see that when you are working on the payoff will be okay. When you work on the payoff, you do from the right to left. You always report the outcome right next to the node like that. Okay. Now next we are going to make decision on event 2. So on event 2, E2, the decision will be, you can see that event, you're gonna pick the best payoff. So we're gonna cut, we're gonna get rid of the payoff. Okay, on number 2, a bit big. Okay, why? Because payoff number 2 is the smaller. So in this event number 2, the outcome will be 22.5. Okay, on event number 3, you have 2 choices. You have 25 and you have 24. So you can get rid of 24. So you can get rid of that, and the outcome will be over here, which is going to be 25. Okay, now moving along, for E2 we have 22.5. For E3 we have 25. Okay, next we are going to make this work on node number 4. Okay, on node 4 you can see that node 4 includes 3 events, which 0.2 times 25 on event for decision 3 plus 0.5 times 26 plus 0.3 times 20. Okay, so node number 4 has the outcome of 24. Okay, so we're gonna put the outcome right next to it. Okay, final decision. Node event number 1. On event number 1, you can see now we have 2 alternatives. One is 24 and another one is 22.5. So we're gonna get rid of the one that's lower, which is alternative 1. So the final outcome will be $24. Okay, we can summarize that. Okay, the best alternative is alternative 2, which the expected payoff is $24. 24. Okay, so that is example 1.8. Okay, for example 1.9. Example 1.9. Okay. Example 1.9 will be the application. So these are like a real world application of the decision tree. Okay, and what we need to do is we have to interpret this information into a decision tree. So I hope that you follow this exercise with me. Okay, so we're gonna go back to my exercise. Okay, on this exercise we are going to use some like a drawing tool. Okay, first we're gonna start out with like a rectangular. So that one will represent, we call decision node. Okay, another one we can also are going to use, we call a circle. That one will represent event node. Okay, and we also gonna use an arrow. Okay, an arrow will represent. Okay, the arrow will represent like a option. Okay, so in this particular example, okay, the manager is trying to decide whether or not to buy one machine or two machines. So we can start out with an event node. Okay, with the decision, and then you branch out to do either one machine or two machines. Like that. So we have that one machine, or we have two machines. Okay, now after that, if one machine is purchased and demand proves to be very excessive, the second machine can be bought later. Okay, and some sale will be lost. Okay, in addition, the cost per machine will be lower if both are purchased at the same time. The probability of low demand is 0.2. In this case, you can see that if it gives you an opportunity, means a probability, meaning that this branch will follow by the event. Okay, and each event will have each event node will follow by two events. One is when the demand is low, another one when demand is high. Okay, so we're gonna this one gonna branch out into two. Okay, so one is high. When it high is high or point 0.8. Another one is low demand 0.2. Okay. Okay. Now, next we're gonna trying to put every all the payoff. So probability of low demand is 0.2. Okay. The first paragraph, the last sentence said the after sale net present value of the benefit of purchasing the two machines together is 90,000 if demand is low. So if you buy two machines together, demand is low, the payoff will be 90,000. Okay, and then if demand is high, 180,000, like that. Okay. On the other side, the second paragraph, with one machine purchase, demand is low, the payoff will the net present value will be 120,000. If demand is high, you have three choices. You have three options. So this one you can have different options to follow. Okay, this option may include one, two, three. Okay, the first one said that if you do nothing, okay, and you will get 120,000. Okay, if on the other hand you subcontracting, you get 160,000. Thus, if you buy second machine, you will get 140,000. Okay. Now, when you draw a tree, you draw from left to right. When you make decision you make from right to left. So the first decision to make is over here. So we're gonna first maybe cross it out. So that one is the highest. So you're gonna cross out that. Okay, cross out that. Okay, and also that one is gonna be low, so you're gonna cross out that. Okay, so in this case, the outcome from this decision node will be 160,000 over here. Okay, and then you can see you have two event nodes. One is node number 1, another one called node number 2. Okay, for node number 1, the outcome will be you will get 0.8 times 160,000 plus 0.2 times 120,000. Okay, for node number 2, we'll get 0.8 times 180,000 plus 0.2 times 90,000. Okay, as you compare between two nodes, you can see that node number 1 is lower than node number 2. So also sometimes we just report like that. Report right next to it. Okay, so we're gonna cancel. We're gonna maybe try to maybe cancel out that. Okay, that's pretty. Okay, so the final decision will be you're gonna follow node number 2. Okay, so in summary, we will how many machines should a company buy initially? The firm should buy 2 machines, and the expected payoff will be 162,000. Okay, so on example number 1.9, okay, that's how you do it. Okay, and student will have a chance to work on homework, and on homework make sure that you pay attention to some note. Like for example, if organization lose money, it meaning that the payout will be negative. Okay, and for example number 1.9, number 1.10, student may do this on their own time, okay, or practice it. Okay, on example 1.10, okay, if you do it correctly, small plant, okay, will get about 12.2 million. Large plant will get about 14.1 million. Okay, and then the answer will be large plant. Okay, and I hope that student work on it. Okay, thank you very much.